Section 6.2b. Word problems that we're going to look at in this section are going to be just like the ones that we had using law of sines, only we're not going to be able to use law of sines because we're not going to know an angle and a side opposite in the triangle we're looking at. An example 4, a pitcher's mound in softball is 46 feet from home plate, and there are 60 feet between the bases. How far is the pitcher's mound from first base? A couple of assumptions in this problem that they assume that you know are that when we're talking about a softball field or a baseball field for that matter, that when you go from home to first to second to third back to home, that those are all right angles on a softball field. So if I draw an entire softball diamond here, we know that there are 60 feet between each of the bases. We know the distance from the pitcher's mound to home plate is 46 feet, and what we're interested in finding is that distance right there from the pitcher's mound to first base. If I pull out just this triangle, that's the triangle that's going to allow us to solve for that distance x, so I'm just going to redraw it over here. 46 feet from the mound to home plate. We don't know how far it is to first base. We know that that distance is 60 feet. So back here in the picture, again, you're reminded that each of these angles are right angles. So that means if that's a right angle and the pitcher's mound is directly in straight line from home plate to second base, that this angle right here then has to be half of that, which is 45 degrees. From here, go ahead and use law of cosines. X squared, side we're looking for, equals 46 squared plus 60 squared minus 2 times 46 times 60 times the cosine of 45. We can plug all that into your calculator in one step. You should get 1812.77. Take the square root, and that means the distance from the pitcher's mound to first base is 42.58 feet. Example 5, a ship travels 60 miles due east to point B, then adjusts its course northeast after traveling 80 miles in that direction to point C. The ship is 130 miles from its point of departure. What is the bearing from point B to C? First thing I'm going to do once again is draw a picture of this situation. Here's its point of departure. Begins traveling due east. That means straight east to point B for 80 miles. It then adjusts its course northeast. So if I draw in a north-south line here, we know the ship then is going to travel in this direction to point C, and it goes 80 miles in that direction. Sorry, this down here was 60, not 80. Now we're looking for the bearing from point B to point C. We know now at point C, it's 139 miles from its point of departure. So the angle that we're looking for is the bearing from point B to point C. So B, we know it's going to be from the north. We're going to go so many degrees to the east to get to point C. So we're looking for that angle right there. This is how our final bearing is going to be written. We just need to know at what angle is this here. Well, with law of cosines, I can find that angle in blue pretty easily. I know that this portion of the angle right here is a 90-degree angle because this is a north-south line, and from D to B was an east-west line, so I can just subtract it from 90 to get that once I know the entire angle B. So plug into law of cosines again. 139 squared equals 60 squared plus 80 squared minus 2 times 60 times 80 times the cosine of angle B. 60 squared plus 80 squared, subtract that over from 139 squared, you get 9321. 2 times 60 times 80, negative 9600. Cosine of B, divide by negative 9600. Take the inverse cosine then of that, and we get angle to be 166 76.153 degrees. That, remember, is all of angle B. I need to subtract 90 from that to get just the bearing here in green that we're looking for in the triangle. And that is going to be, once we subtract 90, 76.153 degrees. So our final bearing is north, rotating that many degrees to the east, which is 76.153. And there's our final bearing.